Hello everyone. Today we will discuss the orbital hybridization or orbital overlapping. We all know that the atomic number of carbon is 6. We all know that the atomic number of carbon is 6 and it will exhibit the electronic configuration as 1s2, 2s2 and 2p2, right? According to this, the valency of the carbon is 2, right? The valency of the carbon is 2. But in the case of methane, methane is an organic compound which has only one carbon atom. In the case of methane, it has bonded with 4 hydrogen atoms. There are 4 hydrogen atoms in the case of methane. If the valency is 2 means it has to be bond with only 2 hydrogen atoms. But this is not happened in the case of methane. The carbon is bonded with 4 hydrogen atom. It is bonded with 4 hydrogen atom. This means the electronic configuration of carbon is wrong. This is wrong electronic configuration. Then what is the exact configuration means, right? It will exhibit, carbon will exhibit 1s2, 2s1 and 2p3. Right here, the electron which is in 2s orbital will jump to the vacant. Let us consider this as 2px, 2py and 2pz. Px and py are having 1 electrons each. In the excited state of carbon electronic configuration, the lower energy, the electron which is in the lower energy, that is 2s, will jump to the 2pz orbital. Hence it will exhibit the electronic configuration as 1s2, 2s1 and 2p3. Now the carbon is having 4 valence electrons, right? 4 valence electrons. Hence the methane will exhibit 4 valencies. Okay, now why carbon is having 4 valency means, due to attain the stable electronic configuration, the lower energy 2s electron will jump to the higher energy 2pz orbital. Hence it will get 4 valence electrons. Hence in the case of methane, the carbon is bonded to 4 hydrogen atoms. 4 hydrogen atoms. But we know that the bond length between CH in the case of methane is same. The bond length is same. We know that the electronegativity of carbon is more than hydrogen. If this is the case, how it will be possible? How the bond length will be the same? It will exhibit difference, no? But in the case of methane, the CH bond length is same. This happens due to hybridization of orbitals. What is meant by orbital hybridization? So what is meant by orbital hybridization? Orbital hybridization, it is a process. Orbital hybridization is nothing but it is a process in which the atomic orbitals, I will write here, orbital hybridization. Orbital hybridization is a process in which the atomic orbitals having nearly equal energy will overlap or will combine together to form to form to form a new set of equivalent new set of equivalent orbitals are called as, these orbitals are called as hybrid orbitals. orbitals, and the process is known as orbital hybridization. The orbital hybridization, it is a process in which the atomic orbitals which are having nearly equal energy means we know about we know about S, P and D, F, right? The energy between S and P is less, but the energy between S and D is more, and energy between S and F is still more, right? So the orbitals which are having nearly equal energy, that will combine together to form a new set of equivalent orbitals. So if S will overlaps with S, because those S orbitals are having same energy, and S will overlaps with P, P orbital, as it is having less difference in the energy, and P will overlap with D orbital. P will overlap with D orbital. D orbital, and S will not overlap with D orbital, as the energy difference between S and D is more, and the energy between S and F is also more. Hence, S will not overlap with D and F. Similarly, P will not overlap with F. P will not overlap with F. The energy difference between two atomic orbitals must be least. They must have nearly equal energy. Then only they combine together to form a new set of hybridized orbital. New set of hybridized orbitals which are having equal energy. These hybridized orbitals are having these hybridized orbitals are having equal energy. Equal energy. Hence, these will called as degenerated degenerated orbitals. Hybridized orbitals were also called as degenerated orbitals, as they are having equal energy. This was the orbital hybridization was first proposed by Linus Pauling, Linus Carl Pauling, or we can also say Linus Pauling, in 1931. In 1931, and he also got the Nobel Prize for this work in 1952. The scientist named Linus Pauling is first proposed the orbital hybridization will happens between the two atomic orbitals which are having nearly equal energy, and the new set of orbitals which are equivalent and having equal energy, hence they will called as degenerated orbitals. So what are the characteristics of hybrid orbitals means? They formed by the mixing of orbitals which are having nearly equal energy, and the hybridized orbitals were having equal energy, and that is called as degenerated orbitals. They are more directional. Directional than pure atomic orbitals, and they will form the hybridized orbitals. The hybridized orbitals orbitals forms stronger sigma stronger sigma bonds due to better overlapping between the two orbitals, and these hybridized orbitals will use to determine the geometry geometry and bond angles bond angles of a molecules, right? Let us discuss the examples. We can consider alkanes, alkenes and alkynes. Let us discuss the methane, CH4. Methane is a organic molecule which is having only one carbon atom, and it comes under the classification of alkanes. Alkanes. Alkanes are nothing but they are having only sigma bond, and which possess the general formula CnH2n plus 2. right? Alkanes are having the general formula CnH2n plus 2. We all know that the carbon atomic, which is having atomic number 6, that will possess the excited state electronic configuration as 1s2, 2s1 and 2p3. Hence the valency of the carbon will become 4, right? Hence the valency of the carbon will become 4. And the energy difference between S is different and P is different. The energy of uh, 2s has lower energy and 2p has higher energy. Hence depending upon the bonded molecules, if there is 4 hydrogen atoms were there, hence all the 4 atomic orbitals, that are 2s and 1 2s orbital and 3 2p orbitals, will combine together to form 4 degenerated hybridized orbitals. 4 degenerated hybridized orbitals are called as sp3 hybrid orbitals. sp3 hybrid orbitals, right? And each orbital is having one electron. Each orbital is having one electron, and these sp3 hybridized orbital are having same energy. Same energy. Hence they are called as degenerated state. Degenerated states, right? Now all the sp3 hybridized orbitals of carbon atom will overlap with 1s orbital of hydrogen. 1s orbital of hydrogen will give one electron to form sigma bonds. Sigma bonds, right? Let us discuss the geometry of the CH4 carbon, which is sp3 hybridized and having 4 sp3 hybridized orbitals, and these degenerated orbitals will occupy in the space to attain higher stability, and each orbital will repel each other as they possess unpaired electrons. Hence they exhibit some bond angle. They exhibit the bond angle of 109.5 degree. The bond angle between two sp3 hybridized orbital of a carbon atom is 109.5 degree, as the bond angle is formed due to these hybridized orbitals are having equal energy and they possess repulsion between the electrons. Each hybridized orbital is having one electron. The electron repulsion is there between sp3 hybridized orbital. Hence they possess the bond angle of 109.5 degree, right? Now these sp3 hybridized orbitals will overlap with 1s. This is 1s orbital of 1s orbital of hydrogen. The 1s orbital of hydrogen, we know that the electronic configuration of hydrogen is 1s1. So it is having one electron. The electron which is in the 1s orbital of hydrogen will combine with the electron present in sp3 hybridized orbital to form sigma bond. There is a formation of sigma bond. The hybridized orbitals will form sigma bonds, right? And there are 4 hydrogen atoms. Each hydrogen atom will form sigma bond with 4 sp3 hybridized orbital to form a methane, right? The sp3 hybridized orbitals of the carbon atom will combine with 1s orbital of the hydrogen to form a methane molecule with bond angle of 109.5 degree and possessing the geometry of tetrahedron. Tetrahedron, which is three-dimensional structure. Hence we can write methane as carbon and the two CH bonds are in the plane. One is above the plane and another one is below the plane. This is having three-dimensional structure, and the bond between two sigma bonds is 109.5 degree, which exhibits the bond length of 154 picometer. or 1.54 angstrom. And in the case of sp3 hybridization, the S character is 25% and the P character is 75%. As we discussed earlier, it is having higher P character, that means it is having high donor ability. High donor ability. The donor ability is increases with the P character. We have discussed this in previous videos. Please go and check that one. Let us discuss the bonding in case of ethene. Ethene. It comes under the classification of alkenes. Alkenes which are having general formula CnH2n, right? Ethene is the first alkene, right? Ethene is having 2 carbon atoms and 4 hydrogen atoms, right? Ethene is nothing but C double bond C. Each carbon will bonded with 2 hydrogens, and here 2 carbon atoms were there. Let us consider this is carbon number 1 and this is carbon number 2. Both the carbon are same. Just to represent, I have used 1 and 2. We know that the atomic number of carbon is 6 and it exhibits the electronic configuration as 1s2, 2s1 and 2p3. There are 4 valence electrons in the case of carbon atom, and another carbon is also having same electronic configuration 1s2, 2s1 and 2p3, right? Each carbon atom is having 4 valence electrons, and here the one carbon atom is bonded with another carbon atom and 2 hydrogen atoms. Bonding is there in the number of 3. Hence, 2s orbital and 2p orbital will undergo hybridization to form 3 sp2 hybridized orbital. sp2 hybridized orbitals, right? And each are having 1 electron. And if this is a px, this is py, and this is pz, 1 s and 2 p orbitals were overlapping, hence it is known as sp2 hybridization, right? The unhybridized p orbital is also there, and which is also having 1 electron. Similarly, this carbon will also undergo sp2 hybridization and forms 3 sp2 hybridized orbital and having 1 unhybridized p orbital. Now, the sp2 hybridized carbon will overlap with another sp2 hybridized carbon atom. The one carbon atom, there are 2 carbon atoms and each are having 3 sp2 hybridized orbital. There are 3 sp2 hybridized orbital. Each carbon will carrying 3 sp2 hybridized orbital which are having 1 electron each, right? Another carbon is also having 3 sp2 hybridized orbital. Both the carbon are having 3 sp2 hybridized orbital, and this carbon is also having 1 electron, and these sp2 hybridized orbitals are also having 1 electrons. Hence, the carbon-carbon bond is sigma bond. The bond between 2 sp2 hybridized orbital is a sigma bond. Along with this, the carbon possesses unhybridized p orbitals. Unhybridized. Each carbon will possesses unhybridized p orbital, and that one is also having 1 electron in it, right? Now there are 2 hydrogens with each carbon, and each hydrogen will donate 1 electrons with 1s orbital. 1s orbital of hydrogen will combine to sp2 hybridized carbon atom to form sigma bond, right? Here also the 1s orbital of hydrogen will form a sigma bond with 2 sp2 hybridized carbon atom in the case of ethene, right? And there are unhybridized p orbital. They will overlap laterally. There is a lateral overlapping is there between the 2 unhybridized p orbital, right? We know that The lateral overlapping between the p orbital will form pi electron cloud or pi bond. There is a pi bond formation. Only one p orbital is there, hence there is a formation of one pi bond. Let us discuss the geometry of the alkene, that is ethene. There are two carbon atoms and each carbon is and there is a one sigma bond and another pi bond is there between two carbon atom, and these carbon atoms are bonded with two hydrogen atoms. Each carbon is bonded with two hydrogen, and the bond and this geometry is trigonal planar. Trigonal planar, and the bond angle is 120 degree, and the carbon carbon bond length is, the double bond length is 134 picometer. The bond between carbon carbon is 134 picometer, and it will exhibit the geometry of trigonal planar and the bond angle of 120 degree with a bond length of 134 picometer. Let us discuss the next example, that is alkyne. The case of alkyne, for the best example is ethyne molecule. Ethine comes under the classification of alkyne, which exhibits the general formula of CnH2n minus 2. Right? Alkyne is nothing but that are having triple bond. The alkynes will having triple bond. Ethine means there are two carbon atoms, C2, according to this general formula, C2H 2 into 2 4 minus 2, C2H2. This is the molecular formula of ethine molecule. There are two carbon atoms and two hydrogen atoms. We can represent this is a carbon number 1 and this is a carbon number 2. So the carbon will exhibit the electronic configuration as 1s2, 2s1 and 2p3, and the s orbital is having 1 electron and the p orbital is having 3 electrons. Similarly, another carbon is there that is also having the same electronic configuration, 1s2, 2s1, 2p3, and that is also having 1 electron in s orbit, 2s orbital and 3 electrons in 2p orbital. Now the carbon is bonded with another carbon and one hydrogen, right? Hence there is a overlapping between two atomic orbital. The overlapping is between two atomic orbital, in which the one orbital of 2s and one orbital of 2p will combine together to form two degenerated sp hybridized sp hybridized orbitals. These are sp hybridized orbitals which are having one electron each, along with the presence of unhybridized p orbital. These are unhybridized p orbitals. And similarly in this case also, one 2s orbital and one 2p orbital will combine together to form two degenerated sp hybridized orbitals, along with the presence of two unhybridized p orbitals. Right? Now the one sp hybridized orbital of one carbon will overlap with another sp hybridized orbital of another carbon. So there are two carbon atoms, each are having two sp hybridized orbitals, and each will carrying one electron. Right? This is also having two sp hybridized orbitals and that will also carrying one electron. Hence sp hybridized orbital of one carbon and sp hybridized orbital of another carbon. Hence there is a formation of carbon carbon sigma bond, and remaining two hydrogens will form a bond with another sp hybridized orbital, and there is also formation of sigma bond. Right? There is also formation of sigma bond, and there are two unhybridized p orbitals. Each carbon will possess two unhybridized p orbitals. There are two unhybridized p orbitals and that are having one electrons each. Both carbon are having unhybridized p orbital which will possess one electrons each. This carbon is also having two p orbitals, right? This is why, because only two orbitals will undergo hybridization to forming two sp hybridized orbitals, px, this is py, and this is pz. Let us consider this is pz and this is py. Pz orbital will overlap with another pz orbitals, and there is a formation of pi bond, and py orbital will overlap with another py orbital, and there is also formation of pi bond. So there is a pi 2, there is a formation of two pi bonds, right? The carbon and carbon are having three bonds, in which the one bond is sigma bond and two bonds are pi bonds, and hydrogen is also bonded with carbon atom, and this exhibit linear structure, not geometry, linear geometry with bond angle of 180 degree. Bond angle is 180 degree and it exhibit linear geometry, right? Carbon bond length is 120 picometer and the carbon carbon bond length is 120 picometer. Let us summarize all these three things in the form of table. Let us summarize all the concepts in the case of this table. We have discussed sp3 hybridization and sp2 hybridization and sp hybridization. In sp3 hybridization, how many orbitals are mixed means 3 orbitals, 4 orbitals were mixed. 4 orbitals are mixed. S orbital is mixed with 3 p orbitals, right? Number of hybrid orbitals 4. There are 4 hybridized orbitals. The geometry is tetrahedron, and the bond angle is 109.5 degree, and the bond length is 154 picometer, right? In the case of sp2 hybridization, there are 3 hybridized orbitals. Here the overlapping is taking place between one s orbital and two p orbitals, and there is a formation of 3 hybridized orbitals. The geometry is trigonal planar, and the bond angle is 120 degree and the bond length is 134 picometer. And in the case of sp hybridization, there are 2 orbitals undergo hybridization, one s orbital and one p orbital will undergo hybridization, and there is a formation of 2 hybridized orbitals, and the geometry is linear and exhibit 180 degree bond angle with 120 picometer bond length, right? In case of sp3 hybridization, p character is more and this exhibit high donor ability, right? As s character increases, donor ability will decreases, and the bond length, what is the bond length? That is, bond length is decreases and bond strength is increases along with the increase in the bond angle, right? All these things, as s character increases, as here the s character is more in the case of sp hybridization, right? It exhibit lowest bond length and lower donor ability and higher bond angle, and the bond strength, the bond strength in the triple bond is more than double bond and sigma bond. The strength of the bond is increases as s character increases, right? In previous video we have discussed all those things. Easiest method to determine the hybridization of carbon, oxygen, nitrogen. According to all these concepts, we get to know that all sigma bonds are single, or all single bonds are sigma bonds. We know that all single bonds are sigma bonds. All single bonds are sigma bonds, and all double bonds contain one sigma bond and one pi bond, right? And we also know that all triple bond all triple bonds will contain one sigma bond and two pi bonds, right? And only sigma bonds are formed in the case of sp3 hybridization, right? And one double bond and one sigma bond and one pi bonds are formed in the case of sp2 hybridization. Similarly, we know that one sigma bond and two pi bonds were formed in the case of sp3 hybridization, right? If this is the case, we can easily determine whether the carbon or oxygen is having sp3 hybridization or sp2 hybridization or having sp hybridization. If one sigma bond and two pi bonds means that is sp hybridization. Let us discuss with some examples, then you will understand. Let us discuss the hybridization of the carbon, nitrogen and oxygen in the following compounds. We know that if there is no pi bond means that is sp3 hybridized. If one pi bond is present means that is sp2 hybridized. If two pi bonds are there means there is sp hybridization, right? According to this we can solve this example. In this carbon there is no pi bond, hence it is sp3 hybridized carbon. Similarly, this nitrogen is also having no pi bond and it is also having sp3 hybridization, and this carbon possesses sp3 hybridization due to there is no pi bond, and this is also possesses sp3 hybridization, and this carbon is having one pi bond, hence it possesses sp2. One pi bond means that is sp2, and this carbon is also having one pi bond and it is also possesses sp2 hybridization. The nitrogen is having no pi bond, that means it is having sp3 hybridization, right? If in the case of exam they will be like this, the resonance will happens between the nitrogen and the double bond. If that is the case means this is sp2 hybridized, this is also sp2 hybridized, and this is sp3 hybridized carbanion, right? We have to think like that. In exams they will give like this. Okay, this carbon is having no pi bonds, that is sp3 hybridized carbon, and this is also having sp3 hybridization, and this carbon is having only one pi bond, that means it is sp2 hybridized carbon, and this carbon is having two pi bonds, right? There are two pi bonds means it is sp hybridized carbon atom, and this carbon is having only one bond, one pi bond, this is sp2 hybridized carbon atom. The nitrogen is having no pi bond, that means this is sp3 hybridized nitrogen atom. So in the case of next example, the carbon possesses sp3 hybridization, this carbon is also possesses sp3 hybridization, and this carbon possesses sp2 as it contains only one pi bond. Nitrogen is having sp2 hybridization as the nitrogen is having one pi bond, and this nitrogen possesses sp3 hybridization. In the case of methanol, CH3 possesses sp3 hybridization. Oxygen is also having no pi bond, that is also having sp3 hybridization, and in this ester this carbon possesses no pi bond, hence this is sp3 hybridization. This carbon possesses one pi bond, hence it is sp2 hybridized carbon atom, and this oxygen possesses one pi bond and it is sp2 hybridized oxygen. This possesses no pi bond, hence it is sp3, and this possesses sp3 hybridization. Similarly, the carbon in CO2 has two pi bonds. There are two pi bonds, hence it is sp hybridization. The oxygen is having one pi bond, hence it is sp2 hybridized oxygen. This oxygen is also sp2 hybridized oxygen. This like this we can determine the hybridization of the atoms based on the pi bonds. I hope you will understand. Thank you. I hope you will understand. Thank you. I hope you will understand. I hope you have understand the concept. Thank you for listening.